Welcome to 10.3. Today we're going to talk about ellipses. Let's take a look at the joke. I gave you the Monday joke mostly because I thought it was funnier. Also, I'm making this on a Monday, so there you go. Yesterday I parked in the C section of the parking lot. I had to climb out of the sunroof. That's funny. Okay, an ellipse, if you look at these conic sections over here, because we talked about conic sections are how are we cutting up a cone. And so if you look at this ellipse over here, it's just a different way that we cut up a cone, and pretty much it's an oval. Yep, we're just talking about ovals today. So because we're talking about this not necessarily in a function setting, I want to give you a more geometrical definition of what an ellipse is. Ready for this? Ellipse is the set of all points whose distance from two fixed points which are called the foci or foci. I usually call it foci. Some people call it foci. I don't think it really matters. Just don't call it foci, okay? Don't be uneducated. Okay, so from two fixed points called the foci, add up to a constant. Now, what the heck does that mean? Here's what we got going on. Any ellipse, or oval, as you might call it, has two focal points, foci. And what's going on is that if I pick any point on this edge, or maybe I pick a point over here, no matter what point you pick, those two lengths are going to add up to equal the same thing, always. There's a good way to show this on this website here. Here, I can drag around this point on the edge, and you see how I just kind of like what it's doing with this segment here. Like, no matter how I move it, those two segments are always going to add to a constant. And so that's what's going on with an ellipse. And so I just wanted to take a moment to show you that. Oh, wrong folder. Okay, we're back. Okay, so that's pretty much all I'm going to make you do with that specific definition. Because what I want to do now is just jump into the equation. I'm going to start by drawing an ellipse. I'm going to make this look like so. I'm going to make it go, I'm going to put my center at the origin and go 5 up and down, 1, 2, 3, 4. There's a vertex, 1, 2, 3, 4. There's another one. And then I'm going to go 3 out, 1, 2, 3, 1, 2, 3. All right, remember how we've talked about class as a safe place. We don't judge each other based on how we draw our circles. Well, we're really not going to judge each other based on how we draw these ellipses, because let's just say struggle bus. Safe place, remember. Okay, here's what we got going on. Here is your standard form of an ellipse. Here we go. We got x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1 every single time. That's our standard form. Now let's define what all of this looks like. Well, if I come here to the center, that center is going to be the coordinate hk. This a value, this is going to be the distance from the center to the horizontal vertice, or let's just call it No, we'll call it vertice because we're being specific. Vertice. Now I'm confused if that's how you spell it. I'm going to call it vertex. It's fine. Okay. Horizontal vertex. So here's what we got going on. This horizontal distance is A. It could also happen on the other side. Both of those would represent A because that is a distance. Well, B is going to be the distance from the center, you guessed it, to the vertical vertice. I'm going to call it vertices because that's plural. Okay, so here we got B. And that also happens down here. And remember we talked about the whole definition of an ellipse is based on two foci. So you do have to have a focus in here. And that's a letter that you don't see in this equation. Don't see it because it's the letter C. This is the distance from the center to the foci. So here's what you need to know, particularly with this. I'm going to leave a little bit of space under where I wrote that in yellow. Here's what you need to know. The major axis, and that is a definition we'll be going off of, is the longer axis. And that also determines what orientation of ellipse we have going on. So for our example that we drew in, this is a vertical ellipse because the major axis goes up and down. And something you need to know with the major axis is that you always have the vertices and the foci are always going to be on the major axis. The minor axis is the shorter axis. And we call the endpoints of the minor axis the co-vertices. So at least for this drawing that we put in, my vertices are going to be 0, 5, and 0, -5. My co-vertices are going to be -3, 0, and 3, 0. Okay, as far as like, well, how do I know where to put the foci? Well, we have an equation. It's based off of Pythagorean theorem, and I don't feel that I want to go into depth on that over this kind of video format, but here's what I need you to know, is that basically if I was to create a right triangle with A and B over here, if I wanted to find the value of C, which is going to look something like this, it happens down here as well. By manipulating the Pythagorean theorem, here's what you got. I can tell you that C squared equals A squared minus B squared. If you really want to know where that comes from, shoot me an email and I will let you know. But this is what this looks like for us. So for this equation, or excuse me, this ellipse, I can see that my A value is 3 and my B value is 5. I guess if I want to be picky about this, well, we'll get there in a second. I know that C squared equals A squared minus B squared. So I get 9 minus 25. So I know that C squared equals -16. This is where, if I want to get picky, because we're focusing on a distance, there are too many good puns in this. Okay, we are focusing on a distance. Distance is a positive thing. So that means I don't even have to worry about this being a negative number. We're taking absolute value because it's a distance. So C squared equals 16, then I know that C equals 4, which means my foci are going to lie at 0, 4, and 0, -4. And this page in all its glory, I want to underline that for consistency. This is everything you'll be going off of for this assignment. Look at it. It's color-coded. It's beautiful. I hope you also made it really pretty in your notes because this is our big idea. This is what we're going off of. Just know that some ellipses, they're vertical because, you know, the major axis is going up and down. Sometimes they might be horizontal because the major axis will be going left and right. And it just depends on your equation on the values of A and B. So let's take a look at an example. We're just going to start by graphing some stuff. Okay, so let's start by graphing the quantity x minus 1 squared over 36 plus y minus 2 quantity squared over 9 equals 1. Okay, let's start by picking out our center. If you remember from the equation, it was opposite h and opposite of k, which you should be used to. So my center is +1, +2. Well, this quantity underneath x is a squared. So if a squared is equal to 36, then I can square root that, and I know that a is going to be 6. This 9 represents b squared. So I know that b, if I take the square root of 9, is going to equal 3. And that's all we need to draw the ellipse. So I'm just going to do my best over here. 1, 2, 3, 1, 2, 3. Okay, so my center, we'll draw this in blue, sure. My center is at 1, +2, which means I'm gonna have to go taller up here. Which hopefully doesn't cut out in the video, but it might, who knows. Okay, so my a value is 6. Remember, a is the distance along the horizontal axis. I remember it because it's underneath x. X is a horizontal variable. So I'm going to go out 6, left and right. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. And now b, since it's underneath y, that's going up and down. 1, 2, 3. 1, 2, 3. And now we don't judge each other based on how we draw our ellipses, because that would be rude. Gorgeous. Great. Okay, let's give you another example here. Let's say I want you to graph 25 x plus 3 squared plus 4 times y minus 1 quantity squared equals 100. Well, I'm hoping you notice that this one is quite a bit different. Something you should know about standard form, I want to bring it over here, is that, look, it always equals 1. Always, always, always. So that means if it doesn't equal 1, you have to manipulate it so that you get 2 fractions and that it equals 1. The easiest way for us to do that is we're just going to divide both sides by this 100. And now when I simplify that, I'm going to get x plus 3 quantity squared over, well, 25 over 100 reduces to 1/4. And the y minus 1 squared, 4 over 100, reduces to 1/25. Oh, would you look at that? Isn't that nice? Okay. So I know my center is at -3, +1, because I'm taking opposites. My a value, remember this is a squared, which means my a value is the square root of 4, which gets 2. And my b value, because this is b squared, is 5. So it looks like I'm going to have a vertical ellipse this time because the larger denominator is underneath y. So -3, +1. Okay, this is going to be interesting. It's fine. -3, there's the center. I'm going to go out 2 in the horizontal direction. 1, 2, 3, 4, 5. 1, 2, 3, 4. Ah, nice. Barely made it. All right, I'm just going to connect that with gray. And there we go. So graphing isn't too bad as long as you just know what each piece refers to, especially with the A and the B. The last thing I want to go over for this first half of the lesson is going to be finding the foci and whatnot based on the equation. So I want you to find the center, the vertices, the co-vertices, and the foci, all based on the equation. So our first example, let's go x squared over 9 plus y squared equals 1. Okay, well, I look at this and it equals 1, so I know it's in standard form. But hold up, wait a minute. Y does not have a fraction. Well, how can you make anything a fraction? Put it over 1, homies. Look at that, 2 fractions. Okay, so center, H and K. If you don't see H and K, that means your center is just going to be 0, 0. Well, fabulous. Okay, let's figure out what A and B equal. Remember, this is A squared. This 9 is A squared, so I take the square root, and I get 3. This 1 is equivalent to B squared, so I take the square root of 1, which turns out is 1. And now, because the larger denominator is under x, I know that this is going to be a horizontal ellipse. So my vertices are going to be along my major axis is horizontal, which means my vertices are going to be moving left and right. So basically, for the vertices, because it's horizontal, I just need to go out 3 in both directions on x. Y isn't changing from the center. So I know I got -3, 0, and I got 3, 0. My co-vertices, well, I have to go out 1 in both directions from the center. So the x part of the center does not change, but I get -1 and 0, 1. Well, the foci, just remember our equation is a squared minus b squared equals c squared. So I know that a squared is 9, b squared is 1. So I get c squared equals 8, and I'm going to take the square root of both sides. And that's going to simplify to 2 square root of 2. And you can simplify that, remember, by doing our fun little factor tree. 2 square root 2. Remember, the foci always lie on the same axis as the vertices. So that means from this 0, dang, I wish I had left a little bit more room, because from here as well, I'm also going to go out that plus or minus 2 square root of 2. That means my foci, I got a -2 square root of 2, 0. The y part isn't changing. And I got a positive 2 square root of 2, 0. Okay, I wanted to give you the example with your center at 0, 0 first, because I think it makes a little bit more sense as far as movement goes. If you're ever confused, draw it out. Drawing it is going to save you sometimes. Here's another example. X plus 2 quantity squared over 25 plus y minus 4 quantity squared over 49 equals 1. Okay, same process. Center, we take opposite h, opposite k, so I get -2, positive 4. Since 25 equals a squared, I take the square root to get 5. 49 is b squared, so I take the square root to get 7. this means that my vertices are going to be along the vertical axis because the larger denominator is under y. So that means, here, I'm going to leave a little bit more room this time so I can write that a little bit better. So my vertices I know are changing with the y. So that's going to be a plus or minus 7 from there. The x part does not change. So we got -2, 4 minus 7 is -3, and then -2, 4 plus 7 is 11. Okay, the co-vertices, I know are going to be plus or minus 5 from that x coordinate. So -2 minus 5 is -7, and the y part does not change. -2 plus 5 is +3, and the y part does not change. Okay, so like I said, if that plus or minus 5, plus or minus 7, if that confuses you, what can you do? Draw it. I'm going to write that in pink. When in doubt, draw it. And now I think that'll connect everything for you if you're still a little bit confused. Okay, but let's talk about the foci. C squared equals A squared minus B squared. And I guess we're getting technical with absolute value because we're talking about a distance. So C squared equals the absolute value of 25 minus 49, which I get -24 in there, so absolute value is going to be a +24. I take the square root, and if we break it down, see that's going to be 4 and a 6, which breaks down to 2 square root of 6. And that, the foci lie on the same axis, they lie on the major axis, which is the larger one, so that's going to change with the y for this one. So plus or minus 2 square root of 6 from that 4. So here's what that looks like. The x isn't changing from the center. Well, 4 minus 2 square root of 6. Hey, guess what? That doesn't simplify, and that's okay. We got 4 plus 2 square root of 6. Okay, and that is part 1 of this lesson.